Hello again. I want to continue where we left off in part 1, talking about functions. Now, most of what we had talked about is epitomized in this program that I brought back from the first video on it. Notice that we have the prototypes. They are copies of the headers, and they appear before the int main. These give us the names of two functions and what kinds of variables they're going to take, kinds of parameters, arguments. These names must be known before they're used. It's more or less a definition. Just as we have a declare of int nm, we're declaring the function names. Functions are called by using their name and putting in parentheses the actual values we want to send, at least in this case. We copy the value of n into the first variable, first argument. We copy the value of m into the second argument. Top and bottom are new variables created for COM to work with. They're not the same places in memory as n and m. This is called passing by value. We pass in the values. We don't tell the program where they are. We don't want the program touching them. That's protection. Now, when you use a variable, it brings back these kinds of functions. They bring back a value. That means the value has to be used. Com nm is a value. That value is going to be printed. Fact top is replaced by a value. That value is going to be divided. It's going to be divided by the value that is replaced fact bot times the value that replaced top minus bot. You can think of this working the following way. When the computer gets to this point where it sees fact, it suspends what it's doing in this program COM, passes the value of top into X. Fact works, does whatever it's going to do, and it returns the value. And now this program continues. It's got its numerator value. It sees a division. It sees a parentheses. Now it sees I have to suspend what I'm doing. I pass bot into X. Fact works its magic, brings back a number. That replaces this here. Times. Again, we suspend the operation in COM. We compute top minus bot. We pass that value into X. The function works, returns the value. Now, we do the numerator divided by this product, whatever that value is, we pass it back into COM up here, and that gets printed because it's in an output statement. So, and remember, the return is just sending back the value. It can only send back one value. It's not allowed to send back 4 or 5 values. It sends back one variable. Now, so far, this is not very different from what we've seen in Python. I don't think it's any different, except I believe in Python, you don't get the protection of the variables. We have protection. Fact cannot change top and bottom. It's just not allowed to. It doesn't know where they are. It's given the value of them one by one, but it's never told where it would go to change them. That is called by value. We'll see a different method in a few minutes. But first, I want to talk about trying another problem. I'm going to play with something called Pascal's triangle. Now, if you are remembering your Western Civ, Blaise Pascal was in the 1600s. Was a mathematician and a philosopher. Mathematics and philosophy were very close. We didn't divorce until maybe 1700s, 1800s, something like that. But he wrote a book on this triangle, but he did not invent it. The Greeks used it. Basically, the Greeks did almost anything in mathematics. The Greeks used it. And the Indian mathematicians worked with it before 1000 AD. So they were quite advanced, and they played with this and used it for many, many things. The triangle is very easy. It looks like this. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Maybe you can see the pattern. Each number, the left column is always ones. Each number is the sum of the number above it. If there's no number above it, that's 0, plus the number to the left above it. So if you look at 6, it's the sum of 3 plus 3. If you look at 10, it's the sum of 4 plus 6. Well, that's a good way to generate it. Unfortunately, we don't have the main tool we need to do that. We haven't covered arrays yet, or vectors, and that's going to come in next, after we finish functions. So we can't do it that way. Instead, we're going to continue along this program we're doing. I'm doing this because this will introduce another kind of function, and it flows naturally from what we've done. So I'm going to tell you that 1 is a combination of 0 things taken 0 at a time. After all, how many ways can I take nothing from nothing? 1 also equals the combination of 1 thing taken 0 times. I can only take nothing from 1 once. And 1 also equals all the ways I can take 1 thing from 1. You can only take the 1 thing that's there. Now, 1 also equals, see, 2, 0. Always the 0 is going to come out to be 1. 2 equals, no, I didn't do that nicely. 2 equals how many different ways I can take 1 thing. So if I have Abigail and Matilda, I can choose Abigail or I can choose Matilda. So one or the other, I have 2 ways I can do it. And to complete that row, there's only 1 way to take 2 things given 2. I have to take both of them. Now, I can keep going. Combination of, now let's line them up a little better. The combination of 3 things taken 0 at a time. 3 is the combination of 3 things taken 1 at a time. I have 3 things. How can I do it? I can take A, B, or C. I can only take, that's the only way I can do it. Now, what about 3 is the combination of 3 things taken 2 at a time. This may seem a little harder. I have A, B, and C. I can take A and B. I can take A and C. Or I can take B and C. There's only 3 ways to do it. Remember, the combination doesn't care about the order that we take things in. And then finally, 1 equals the combination of 3 things taken 3 at a time. Now, when a computer scientist or a mathematician or a scientist looks at something like this, they immediately say, there's a pattern here. There must be a way to use this. So the pattern seems pretty obvious. I bet that you could get the next row. I'll bet you that you put C4, 0, C4, 1, C4, 2, C4, 3, C4, 4. And you could keep doing this and doing this and doing this. Well, the point is we already have a function that computes these combinations for us. So why don't we use it to do the output? Why don't we why don't we use the combination? And what I'm going to do is I'm going to say, I'd like to print 1 row at a time. So what I'm going to do is I'm going to say, input how many rows? I guess I should capitalize a few things there to make it easier. Now, it can't be very large, because again, remember, I can't get a much above 10 in factorial. So I ain't going up much higher than that. And once you tell me that, what I'm going to do is for each row from 1 to from 0 to how many rows, I'm going to print the print a row. And you may discover that there's another loop hiding there. Print a row looks to me like it's also a loop. So when we write this, we'll take that into account. Now again, I want to illustrate using functions here. So I'm going to do this a functional way. What I'm going to do is I want to write a program that will print out 1 row. What I'm going to do in the main line here is I'm going to say, after I print out these combinations, I'm going to ask the user, print out how many lines of Pascal do you want? Now that's a little bit of a lie, because the truth is I'm going to give him 1 more than that, unless she says 0. And I still give him 1 more. I'll give him the 0th row. So I'm going to read in how many rows. I want you to notice that I try to use variables that I can figure out what they mean 3 weeks from now if I look at the same program, or more likely 3 years from now if I look at the same program. Yes, I use N and M, but N and M are embedded in all the work of combinations. That's why I use them. They're just there. I understand they're all there. Now what I'm going to do is I'm going to say the following. For int equal int row equals 0, row less than or equal to how many rows, row plus plus. And what I want to do is print a row. So I'm going to put down print row, and I'm going to pass in the row number. Now it's immediately complaining because print row hasn't got a name. It hasn't got anything to it. I want you to look carefully at that. It's different from com. It's different from fact. I don't want any value back. I wanted to do some printing. I don't want a value back. But C++ insists on knowing what kind of thing is it. So I have to use a word that is important. Void print row. And I have to tell it, of course, that that's an int and semicolon. Void is a name that says, I will use this function alone on a line. It will not return a value. If I put a return in the program that is print row, the machine should complain to me. I can't promise you it will, but it should. It should blow up. It should say, that's wrong. But we never know. The program might accept it. So I'm going to go down here, and I'm going to now put in that function. Void print row int row. And I decided to use the same name this time. I didn't have to. Well, it seems to me that the function's pretty easy, but I just realized I want some pretty output. So, of course, I'm going to have to go to #include iomanip. So I can use setW. So now, if you look over here, what am I doing? I'm printing out C, the row number, 0, C, the row number, I forgot the C in all of those places. Only in that column. C, the row number 0, C, the row number 1, C, the row number 2. So for row 2, I go 0, 1, 2. For row 3, I go 0, 1, 2, 3. Again, it looks like a pattern's developing. So, let's see. It looks like I will say for column int column equal 0 column less than or equal to the row number. That's right. Column plus plus. I am going to C out set W. I think 5 will be enough. And I'm going to print out the combination of the row with the column. Row is fixed, and I'm just going to print out the columns from 0 to however many there are. Then I have to print the indel so I don't get them all in one line, and that's it. There is no return statement. So that's a short little program, but I'm using it because I want you to realize that we can have functions that don't return anything, that do something but don't return something. So let's run this and see how it works. Oh, I got an error somewhere. What did I do? Uninitialized. Okay. Why is the machine up? Oh, that makes sense. I unfortunately used it before I read it. Now, by the way, a couple of you have turned in programs to me. I graded homework 4 this earlier today, and you got that error. You can't use a variable until you've either initialized it or read it in. When I read it in here, that gives it a value, and I can use it here. If I hadn't read it in, I'd have to give it a value before I used it. So let's go. That should take care of that. All right, let's try 10. Oh, I'm sorry. I forgot there are 2. That's the first part. Now let's see if we can get 10 elements. Well, that worked out pretty nicely. And they don't seem to be too high yet. I'm going to try it again and see how far I can go. I'm going to try 15. Oh, bah. 15. Notice the negatives. I can't go that high. It looks to me like after line 12, it didn't work. Again, I would remind you that the computer has finite amount of ability to do arithmetic. It isn't infinite precision. So now we have the kinds of functions we want. 2 different kinds of functions. I'm going to copy this program. Let's see. And bring it over here. And I think I'll put it on a new page. And I'll make it bigger. That's right. Okay. So there's the program. So to summarize, so far we have talked about the header of a function, the arguments of a function, the return statement, the prototype, and one other thing I want to say, the use of the function, or shall I say the call of the function, and by that I mean in a statement for int, double, char, string, all those kinds of things, etc. but alone on a line for void type functions. Well, that's about what we've done so far. The method, now just write it this way. When a function is called, the values of the arguments in the main line, in the caller, are copied into the variables named in the header. This is a translation. At least that's the best way to think about it. This protects the variables in the caller. They can't be changed. And I should say, I'm going to go just above here. We are using call by value. In this case, and then I'll pick up where I left off there. Wet. Now that's the only choice you have in Python. It is not the only choice you have. Oh, pardon me. I don't think you have that choice in Python. They can change. However, we have another approach. And what I'm going to do is I'm going to motivate this, I hope, by a problem. Here's the problem. Given variables A and B, exchange their values. We want a function to do this. There are many problems, especially sorting problems, where you have a lot of values and you want to put them in alphabetical order or numerical order, where you have to, where the argument, the algorithm involves comparing two values, and if they're out of order, exchanging them. So that happens, and we like a function to do it. So I'm going to go over here, and I'm going to try to do that. So, again, I have to find a way to get up there so I can do it. There we are. So File, Close Solution. And now I'll have a new project, and I'm going to call this bad exchange. So you'll see why when I do it. So I will still have the using namespace standard. And I think I want my # include manip. And what I'm going to do is simply have two variables, first and second. And I'm going to say to the user, input first and second. And I'll have the read. Cin first and second. Now I'm going to print them out. So I'm going to see out after the read first equals, I think I'll have a set W5 and of course I'll print out first and then I'll have N second equals, and I'll have another set W5 and I'll have second and indel. By the way, somebody turned in a program and I had to send it back and tell them to send it again because they wrote in one instead of indel. It's an L, in line. Okay, now I'm going to write a program to do the exchange. So I can't return two values. So the only way I can make the exchange is by basically having variables that go in and get exchanged. So I'm going to have a void, and I'll call it exchange, and it will exchange int I need a good name that isn't first and second. Val1 and int val2. And now I'm going to get down here and I'm simply going to say exchange. Exchange for me first and second. And now I'm going to see if it worked. So I'm going to take this line here. I'm going to print it again. After the function, we get this. Some people complain about my making the copy like that. They think it's a little lazy, but I don't. So I'm sure most of you don't either. Now we'll have the program. I do need the return 0 to end this. And now I need my program, which I made void exchange int val1 int val2. Now some people do this totally stupidly. I've seen people try it this way. I'm going to put quotes around that. I'm going to put a comment, pardon me, around that. And it's going to be, and I'm going to go up here and I'm going to put bad code. The reason, well, I'll let you think about it for a second before I give you the reason. I hope you've got some ideas. let's look at it. Suppose val1 is 10 and val2 is 15. Then the first line copies 15 into val1. Val1 is now 15. And now the second line copies val1 into val2, and val2 is now 15. You just can't do it that way. Some languages allow it to do it in parallel, but that's not the way we do it. We have to do it sequentially. The only way to exchange two variables is to have a third one. So I'm going to put another one in. I'm going to have int temp. So we'll just call it temp. And what I do is I let temp equal val1, val1 equal temp, and now val2, pardon me, I knew I was doing something wrong. Val1 equals val2, and val2 equals the value I saved in temp. So what I did is I saved the value of val1 in temp. Then I could wipe out val1 without causing any problem. And then I copied val2 into val1, which wiped out the value of val1, but I had it saved. And then I put the saved value of val1 into val2. So that looks pretty good. Let's print this out again inside the loop. So I'm going to go down here, and I'm going to print this. And I'm going to say, at the end of the function, inside the function, I'm going to have to use val1 equals val1, and down here this is val2, this is val2, and I should probably change this. Now, let's see what happens. Run the program, and I'll put in 10 and 15. Well, in the main, after the read, first is 10 and second is 15. Inside the function, everything looks fine. The val1 becomes 15 and the val2 becomes 10. When we get back to mainline, nothing has happened. So I'm going to copy this and take this over to here. So V, I did have an I there, I think. And now I'm going to go back to the main line, and I'm going to use, well, I'll give you this. I guess I can go up and give you this much. I don't think we need the anything above that. So we'll take this over here. I'll put it in here. Make it bigger. And I'll say, using this function, we get the result below. And I'd like to get it on one page, so I'm going to try get this down just a little. It's going to be tight, but I think I can. I'll take it to 14, and I'll get rid of, no, it did work. So this is the output. Now, that doesn't work. Why? It doesn't work because call by value protects first and second from any meddling in the function exchange. It does not meddle. It doesn't change it. It doesn't know where they are. It can't change it. So we want to be able to. So the solution to this problem, excuse me, I need a little something. Okay. The solution to this problem is we have another way. We can pass variables using call by reference. And I'm not sure. Some people, I think, put it call by name. The two are different, but I've heard that they both seem to be used sometimes, so I'll give you both names there. What this is we pass the address of the argument, not the value of the argument. We tell the function exactly where it should find the variable. That means there's no translation from the main to the call. The call is working with exactly the same places in the memory. Well, the question is, how do we do that? We do that by putting an ampersand before the variable name in the header and prototype. You will find out later, if not in this class, definitely by the next class. You'll probably find it out in this class. Ampersand is read when it's in front of a variable as address of. That's all it is, address of. And it's very simple to fix this program. I go over here, I go up to the prototype, I put the ampersand here. Now, it works the same way if you put the ampersand after the int. Doesn't matter. And now I put the ampersand here, and the ampersand there. And now if I run it, and I pass in 10 and 15, it works. So that's the result now. Go back here. Result is Control V when we use the program. Now I'll copy the whole program so you have it all. And I won't copy the bad exchange because this is now the good exchange. So we'll take that over to here. And we have it copied. So you've now seen that you have two choices of the way to pass variables into a function. Those are the two that are used in C++. If you took a programming language this course, you discover that there are many others. But these are the two that most people know and most people use. And they're they're sort of enough for what we have to do. Now, I think I will stop here. There's going to be one more of these, and then I'm going to give you a homework. So that should happen tomorrow. Although I have a kind of busy day tomorrow, but hopefully it will happen. I don't think you people know, I haven't told you, I lost my cat about a week ago. She had cancer, and she went blind. She was going blind, so I had to put her down, unfortunately. She was a wonderful cat. She was of a good age, but I am now getting 2 new kitties, and they're due tomorrow. So that's part of what I'm going to be busy at tomorrow. And the next time I give you one of these videos, you may hear noise in the background. So we'll see you later.